Hello. We've got a resistance question here using the resistivity equation. We're asked to calculate, there's a combination of steel and copper cables, and we've got to calculate the resistance of 1 meter here. That per meter means simply that the length we're using is 1 meter, and the equation we need is R equals rho L over A. We need to work out the cross-sectional areas. Let's start with the copper. So there are 9 cables. I'm going to use pi d squared over 4 to calculate the cross-sectional area for each of these little cables. That's 8 times 10 to the minus 3 pi d squared over 4. Plugging that into my calculator, 9 times pi 8 times 10 to the minus 3 squared divided by 4 gives me 4.52 times 10 to the minus 4 meters squared. Now for the steel. The steel is going to be the larger diameter subtracting the copper. So that's going to be pi d squared again, this time using 60 times 10 to the minus 3 and dividing that by 4 and subtracting the copper. Pi times 60 times 10 to the minus 3 squared divided by 4 minus 4.52 times 10 to the minus 4. So that gives me 23.75 times 10 to the minus 4. So it's a little bit more steel than copper. Now, I still need to get the resistances. The length is 1. I know the resistivity and I know the area. It's just the resistivity of each one divided by the area of each one. So using the resistivity of copper, that's 4 times 10 to the minus 8, and I'll divide that by 4.52 times 10 to the minus 4. That gives me 8.85 times 10 to the minus 5 ohms. And for the steel, it's the resistivity of steel, 2 times 10 to the minus 7, which isn't anything like the resistivity of steel, but anyway, and I'm going to divide that by 23.75 times 10 to the minus 4. So that's 8.42 times 10 to the minus 5. Now, probably the trickiest bit is to think about the combined resistance. And these two wires essentially are in parallel from A to B, from one end of the cable to the other end. I've got a copper and I've got a steel resistor. So I'm using the parallel equation now. I'm going to do 8.85 times 10 to the minus 5 to the power of minus 1. Add that to 8.42 to the power of minus 1. And then when I get my answer, I'm going to do that to the power of minus 1. And that gives me 4.31 times 10 to the minus 5. And it's ohms per meter because we did it for the length of 1 meter.